For centuries, humanity has gazed at the stars and dreamt of exploring the cosmos. What was once science fiction is now becoming reality. Advancements in space technology are paving the way for an extraordinary possibility: living on other worlds. Imagine stepping foot on Mars, the Red Planet, or building a lunar base on the Moon, our celestial neighbor. This isn't just a fantasy, it's a future we are actively working towards. The drive to explore is deeply embedded in our DNA. From the earliest seafarers to modern-day astronauts, humans have always pushed the boundaries of the known world. Space, with its infinite mysteries and possibilities, represents the ultimate frontier. The quest to colonize other planets is driven by a thirst for knowledge, a desire to secure humanity's future, and the spirit of adventure that defines our species. The challenges of space colonization are immense, but so are the potential rewards. Imagine humans living on another planet, conducting groundbreaking research and tapping into vast resources. Picture children gazing up at a different sky, filled with the wonder of a new world. This is the future that space colonization promises, a future where humanity takes its place among the stars. While the dream of space exploration is inspiring, there are also pragmatic reasons to consider colonizing other planets. The allure of the unknown, the excitement of discovery, and the potential for new beginnings drive us to look beyond our home planet. But beyond these dreams, there are tangible benefits and urgent needs that make space colonization a critical endeavor. Our own planet faces a growing number of threats, from climate change and resource depletion to potential asteroid impacts. The environmental changes we witness today are just the beginning of what could become a more severe crisis. Rising temperatures, melting ice caps, and deforestation are altering the very fabric of our world. Additionally, the threat of a catastrophic asteroid impact, though rare, is a real danger that could have devastating consequences for life on Earth. Establishing a human presence on another world would provide a crucial backup plan for our species. Imagine a thriving colony on Mars or a bustling base on the Moon where humans can live, work, and explore. These outposts would serve as a safeguard, ensuring that humanity can continue to thrive even if Earth faces insurmountable challenges. If disaster were to strike Earth, humanity could continue on another planet, ensuring our survival. This continuity is not just about preserving human life, but also about maintaining our culture, knowledge, and achievements. A new world would offer a fresh start, a chance to build a society that learns from the mistakes of the past and strives for a better future. Beyond survival, space colonization offers tremendous opportunities for scientific discovery. The unique environments of other planets and moons provide unparalleled opportunities for research and experimentation. Scientists could study phenomena that are impossible to replicate on Earth, leading to breakthroughs in various fields of science and technology. Each celestial body in our solar system is a unique laboratory waiting to be explored. From the barren landscapes of Mars to the icy moons of Jupiter, each world holds secrets that could revolutionize our understanding of the universe. The data collected from these explorations could answer fundamental questions about the origins of life, the formation of planets, and the potential for life beyond Earth. By studying the geology, atmosphere, and potential for life on other planets, we can gain a deeper understanding of our own planet's history and the origins of life itself. The comparative analysis of Earth and other celestial bodies could reveal patterns and processes that have shaped our world. This knowledge could also inform our efforts to protect and preserve our planet for future generations. These discoveries could have profound implications for our understanding of the universe and our place within it. As we uncover the mysteries of the cosmos, we may find answers to age-old questions about our existence and our destiny. The exploration of space is not just a scientific pursuit, but a philosophical journey that challenges us to rethink our place in the grand scheme of things. Furthermore, space colonization could unlock vast resources. The minerals and elements found on other planets and asteroids could be the key to solving many of Earth's resource challenges. These extraterrestrial resources could support the development of new technologies and industries, driving economic growth and innovation. The Moon, for instance, is believed to hold valuable helium-3, a potential fuel source for fusion power. Fusion power, if harnessed, could provide a nearly limitless and clean energy source, reducing our dependence on fossil fuels and mitigating the impacts of climate change. The extraction and utilization of helium-3 could revolutionize the energy sector and pave the way for a sustainable future. Asteroid mining could provide access to rare earth elements and other valuable materials, reducing our reliance on Earth's dwindling resources. These materials are essential for the production of advanced electronics, renewable energy technologies, and other critical applications. By tapping into the wealth of resources in space, we can ensure a steady supply of these materials and support the continued advancement of technology. These possibilities make space colonization not just a scientific endeavor, but also a potential economic engine for future generations. The development of a space-based economy could create new industries, jobs, and opportunities for growth. As we expand our presence in space, we will also expand our horizons, pushing the boundaries of what is possible and inspiring future generations to reach for the stars. When it comes to space colonization, two celestial bodies stand out as the most promising candidates: Mars and the Moon. These two destinations have captured the imagination of scientists, engineers, and dreamers alike, each offering a unique set of challenges and opportunities for humanity's next giant leap. Each offers unique advantages and disadvantages, making the choice between them a complex one. The decision is not merely a matter of distance or resources, but involves a deep understanding of the environments, potential for sustainability, and long-term benefits for human civilization. The Moon, our closest celestial neighbor, presents a more manageable target for initial colonization efforts. Its proximity to Earth makes it an attractive option for early missions, allowing for relatively quick trips and the possibility of more frequent resupply missions. Its proximity to Earth allows for shorter travel times and easier communication. This means that any issues that arise can be addressed more swiftly, and the psychological impact of being closer to home could be beneficial for astronauts. The Moon's surface, while harsh and unforgiving, offers features like lava tubes, which could provide natural shielding from radiation and meteoroids. These underground structures could serve as ready-made shelters, reducing the need for extensive construction and offering a safer environment for long-term habitation. Mars, on the other hand, holds the allure of being a more Earth-like planet. Its similarities to Earth, such as the length of its days and the presence of seasons, make it a compelling candidate for colonization. The idea of walking on a planet with a sky and landscape that somewhat resemble our own is incredibly enticing. Though much colder than Earth, Mars has a day-night cycle similar to ours and may have once harbored liquid water on its surface. The presence of water, even in the form of ice, is crucial for sustaining human life and could be used for drinking, growing food, and even generating fuel. The discovery of subsurface water ice on Mars has further fueled hope for the possibility of one day terraforming the red planet, transforming it into a more habitable environment for humans. This vision of turning Mars into a second Earth is a powerful motivator for many in the space community. The choice between Mars and the Moon is not just about logistical considerations, it's also about ambition. The Moon offers a more immediate and achievable goal, serving as a proving ground for the technologies and strategies needed for deeper space exploration. The Moon represents a stepping stone, a testing ground for technologies and strategies that could later be applied to more ambitious missions to Mars. Establishing a base on the Moon would allow us to test life support systems, habitat construction techniques, and other critical technologies in a relatively controlled environment. Mars, however, represents the ultimate goal for many space enthusiasts, establishing a permanent human presence on another planet and potentially terraforming it into a second home for humanity. The dream of creating a self-sustaining colony on Mars is a testament to human ingenuity and our unyielding desire to explore and conquer new frontiers. As we stand on the brink of this new era of space exploration, the choice between Mars and the Moon will shape the future of humanity's presence in the cosmos. Whether we first set up camp on the Moon or aim directly for Mars, each step we take brings us closer to becoming a multiplanetary species, ensuring the survival and growth of human civilization for generations to come. While the dream of living on Mars or the Moon is inspiring, it is a vision that has captured the imagination of humanity for generations. The idea of establishing a new home on another celestial body is both thrilling and daunting. However, the reality of space colonization is fraught with challenges. These challenges are not just technical, but also biological, psychological, and logistical. The harsh environment of space poses significant threats to human health and well-being. The vacuum of space, extreme temperatures, and high levels of radiation are just a few of the dangers that astronauts must contend with. To ensure the survival of future colonists, innovative solutions are required. Scientists and engineers are working tirelessly to develop technologies that can mitigate these risks. One of the biggest challenges is radiation exposure. Space radiation is a formidable enemy, invisible yet deadly. Unlike Earth, Mars and the Moon lack a strong magnetic field to deflect harmful cosmic rays. This means that astronauts are exposed to higher levels of radiation, which can have serious health consequences. Prolonged exposure to this radiation can lead to an increased risk of cancer and other health problems. It can damage DNA, increase the risk of degenerative diseases, and impair cognitive function. To combat this, scientists are exploring various shielding methods, including building habitats underground. Underground habitats can provide natural protection against radiation. Another approach is using Martian regolith, the loose surface material, to provide protection. This material can be used to construct thick walls that shield inhabitants from cosmic rays. Another challenge is the effect of low gravity on the human body. The reduced gravity on Mars and the Moon can have profound effects on human physiology. Long-term exposure to low gravity can lead to muscle and bone loss, cardiovascular problems, and other health issues. Without the constant pull of gravity, muscles and bones weaken over time. Countermeasures such as artificial gravity systems are being developed. These systems can simulate the effects of gravity, helping to maintain the health of colonists. Rigorous exercise regimes will also be crucial. Regular physical activity can help mitigate the effects of low gravity, keeping muscles and bones strong. Resource extraction and utilization present another hurdle. The lack of readily available resources on Mars and the Moon means that colonists will need to be self-sufficient. Both Mars and the Moon lack readily available resources like breathable air, liquid water, and fertile soil. This scarcity of resources poses a significant challenge to long-term habitation. Colonists will need to develop innovative ways to extract water ice, generate oxygen, and grow food in these harsh environments. Water ice can be found in the polar regions of Mars and beneath the surface of the Moon. Growing food in space will require advanced agricultural techniques. Greenhouses and hydroponic systems can be used to cultivate crops in controlled environments. Experiments on Earth, such as growing crops in simulated Martian soil, are already underway to address these challenges. These experiments help scientists understand how plants can be grown in extraterrestrial environments. Scientists are also researching ways to improve space agriculture. By studying how plants respond to different conditions, they can develop methods to increase crop yields and ensure a stable food supply for future colonists.